Dopamine was discovered in the late 1950s, and it was discovered as the precursor, meaning the thing from which epinephrine or adrenaline is made. Epinephrine is the same thing as adrenaline, except in the brain we call it epinephrine. Epinephrine allows us to get into action. It stimulates changes in the blood vessels, in the heart, in the organs and tissues of the body that bias us for movement. Dopamine was initially thought to be just the building block for epinephrine. However, dopamine does a lot of things on its own. It's not always converted to epinephrine. Dopamine is released from several sites in the brain and body, but perhaps the most important one for today's discussion about motivation and reward is something that's sometimes just called the reward pathway. For the aficionados, it's sometimes called the mesolimbic reward pathway, but it's fundamentally important to your desire to engage in action, and it's fundamentally important for people getting addicted to substances or behaviors. So how does this work? Well, you've got a structure in the deep part of your brain called the VTA. The VTA, or ventral tegmental area, contains neurons that send what we call axons, little wires that spit out dopamine at a different structure called the nucleus accumbens. And those two structures, VTA and nucleus accumbens, form really the core machinery of the reward pathway and the pathway that controls your motivation for anything. You can think of them like an accelerator. They bias you for action. However, within the reward pathway, there's also a brake. The brake or restriction on that dopamine, which controls when it's released and how much it's released, is the prefrontal cortex. The prefrontal cortex is the neural real estate right behind your forehead. You hear about it for decision making, executive function, for planning, etc. And indeed, it's responsible for a lot of those. It's this really unique real estate that we were all endowed with as humans. Other animals don't have much of it. We have a lot of it. And that prefrontal cortex acts as a brake on the dopamine system.